Dear friends, welcome to my channel. Myself, Gauru Bharat Kumar, working as assistant professor in the department of CSC. Coming to the artificial intelligence course, the next concept is constraint satisfaction problems. In today's session, we will discuss why we are moving to the constraint satisfaction problems. What are the advantages in the constraint satisfaction problem? What are the goals in the constraint satisfaction problems? So far, we have discussed about the uninformed searching and informed searching in artificial intelligence. Actually, we have two different types of searching techniques are available in the artificial intelligence. One is uninformed search and another one is informed search. Actually, the idea that problems can be solved by searching in a space of states. The idea of uninformed and informed searching algorithm is searching in a space of states. Actually, these states can be evaluated by domain specific heuristic and tested to see whether they are goal states or not. These type of searching techniques are represented by arbitrary data structures. Okay, so coming to the constraint satisfaction problem compared to the uninformed and informed searching, this leads to the invention of a range of powerful new search methods and a deeper understanding of problem structure and complexity. So compared to the uninformed and informed searching, actually the constraint satisfaction problems are working on more complex problems. Okay. Actually, here the constraint satisfaction problems whose states and goal test conform to a standard, it maintains the structured and very simple represent with the help of three components. Those are variables, domains, and constraints. What is the meaning of variables? How we will assign the domain values to the variables? What are the constraints for the problems? We will discuss later. Okay, so search algorithms can be defined that take advantage of the structure of states and use general purpose rather than problem specific heuristics to enable the solution of large problems with the help of backtracking search and local searching algorithms. Compared to the uninformed and informed searching algorithms, here we are apply the backtracking technique. That is the main advantage of constraint satisfaction problem. Here our main aim is to satisfy the problems with the limitations and terms and conditions of those problems. Okay, so perhaps most importantly, the standard representation of the goal test reveals the structure of the problem itself. Here, at the time of solution, the structure is also maintained with the problem and the solution itself. Coming to the constraint satisfaction problem, actually, this is the mathematical questions defined as a set of objects whose state must satisfy a number of constraints, that is also called as limitations. This totally depending on the mathematical questions. Here we will consider the some set of variables, some set of domains, and with the help of constraints. Based on the constraints, we will assign the domain values for the variables. That is main important point here. So that's why the constant satisfaction problems represent the entities in a problem, such as a homogeneous collection of finite constraints over variables, which is solved by constraint satisfaction methods. Actually, coming to the definition related to artificial intelligence, the constraint satisfaction problem is a collection of variables, domains, and constraints. It consisting of variables with constraints. Many important real world problems can be described as constraint satisfaction problems. In artificial intelligence, we have some toy problems and real world problems are also available. The toy problems are solved basically with the help of brute force technique. Brute force technique means here we will find out the solution at any number of random chances, but in the backtracking, definitely we will maintain some format. Okay, so in the constraint satisfaction problems, we will apply the backtracking technique and local searching algorithms. What is the meaning of backtracking? Here we will apply the depth first search is commonly used for solving the constraint satisfaction problems. If we will find out any mistake or any violated the constraint, definitely with the help of backtracking we will move to another way, no problem here. So coming to the real world problems, here we have lot of real world problems are available. These all the examples are related to the constraint satisfaction problems. Here we have some toy problems are also available, but at the time of implementation of with the brute force technique the problems are complicated. That's why we will help of backtracking technique. That's why we will move to the constraint satisfaction problems. Here real world problems are scheduling, building design, planning, optimization or satisfaction, traveling salesman problem, robot navigation, internet searching, automatic assembly sequencing, VLSI layout, Turing problems, registering for classes, Sudoku, crossword puzzles. Actually, what is the goal of constraint satisfaction problem? Here we have three goals regarding to the variables, regarding to the domains, regarding to the constraints. Okay, so actually the first goal of constraint satisfaction problem is an instantiation of a subset of variable s in an assignment of a legal domain value. Here we will definitely indicate the legal variable value to the each variable name. Suppose we will consider the any programming language, we will declare int I is equal to 10. Here integer is related to the data type, int data type. Here I is the variable name, and definitely here we will assign the value related to the integer data type only. Okay, so that's why that satisfies the constraint. Suppose we will indicate int I is equal to 10.5 like that. So here at the time of declaration we will mention the data type as integer, but the assigning value here we will mention the real. Definitely that violates the constraint. So the first goal of constraint satisfaction problem is definitely we will assign the suitable value to the each variable. The second one is definitely here we will use the legal. Okay, here we will not violate any constraints. That is the second goal. Finally, here our aim is to find out the solution. Definitely we will find out, we will assign the each and every domain for the each and every variable. What is the meaning of variable, what is the meaning of domain, what are the different types of constraints, we will discuss in the next session. Thank you very much for your patience.